Hey everyone, imagine a world where swarms of intelligent programs, robots, or virtual assistants work together like seasoned teams, coordinating, negotiating, and solving problems that a single AI can't handle alone. That's the promise of multi-agent systems, or MAS. In the next 15 minutes, I'll unpack what MAS are, why they're suddenly everywhere, and how you can design and use them effectively in products and research. Stay with me. There's practical advice, real examples, and a roadmap to build your first multi-agent setup. First, what is a multi-agent system? At its core, MAS is a collection of autonomous entities, agents, that perceive their environment, make decisions, and act to achieve individual or collective goals. Agents can be software processes, robots, or simulated actors. The magic happens when interactions between agents produce coordinated behavior and sometimes surprising emergent results. Think teams rather than lone heroes. A quick history tour. MAS traces back to early AI research, distributed systems, and agent-based modeling in the 1980s and 90s. Over time, it absorbed ideas from multi-robot teams, swarm intelligence, and distributed constraint optimization. Recent advances in compute, reinforcement learning, and cloud-native orchestration have supercharged MAS research and practical use, which is why we're seeing a renaissance today. Let's break down core agent properties. Autonomous. Agents act without direct human control. Social. They communicate and negotiate. Reactive. They sense and respond to changes. Proactive. They pursue goals and plan ahead, and often they're heterogeneous, different agents with different skills. These properties shape how you design coordination and communication. Architecturally, MAS can follow several patterns: centralized coordinator, fully distributed, peer-to-peer, hierarchical teams, or hybrid models. Centralized systems are easier to manage but less resilient. Fully distributed ones scale and tolerate failures better, but need more complex coordination protocols. Choosing an architecture depends on latency, reliability, and the complexity of interactions you expect. Communication is the lifeblood of MAS. Agents use protocols for messaging, gossip, auctions, or blackboard systems. You'll choose synchronous or asynchronous messaging, design message schemas, and consider bandwidth and security. Common patterns include publish-subscribe for events, contract-net for task allocation, and consensus protocols for agreement, each with trade-offs. Coordination strategies decide who does what and when. You can use market-based approaches, auctions, task allocation algorithms, leader election, stigmergy, indirect coordination like ants leaving pheromones, or explicit planning with joint policies. For large-scale systems, lightweight decentralized algorithms and local rules often outperform heavyweight global planners. Learning amplifies MAS power. Multi-agent reinforcement learning, MARL, lets agents improve policies through interaction. Emergent behavior can appear. Complex team strategies from simple reward structures. But MARL faces instability, non-stationarity, and credit assignment problems. Hybrid approaches, combining heuristics, learning, and symbolic planning, often give the best practical results today. Where is MAS used right now? Everywhere. Autonomous vehicle coordination, drone swarms for mapping or delivery, smart grids balancing energy, multi-robot warehouses, traffic optimization, financial trading bots coordinating strategies, and even virtual game NPCs that form teams. I'll highlight two short examples: warehouse robots collaborating on order fulfillment, and drone swarms doing search and rescue. MAS brings big benefits but also challenges. Key risks include communication failures, emergent unwanted behavior, safety and verification issues, scaling complexity, security vulnerabilities, and fairness when agents represent different stakeholders. Mitigation requires robust testing, simulation, formal verification where possible, and well-designed reward functions and fallback behaviors. If you want to build MAS, here's a practical stack: simulation tools like Mesa, NetLogo, and Gazebo, MARL libraries like RLlib, PettingZoo, and stable baselines with multi-agent wrappers, orchestration and messaging via ROS2, MQTT, Kafka, or custom gRPC. Cloud platforms and container orchestration Kubernetes help scale agent instances. I'll also mention tool combinations for prototyping versus production. Practical design tips. Start with a simulator and simple baselines. Define clear agent interfaces and message schemas. Prefer local rules and graceful degradation. Design incentives carefully to avoid gaming. Instrument everything for observability. Test emergent behavior in many scenarios and use hybrid control, rule-based safety layer plus learned policies. These steps reduce surprises and produce robust systems. Quick case study. Warehouse robots. Problem: coordinate hundreds of mobile robots without collisions, while maximizing throughput. Solution: hierarchical mass, local controllers for collision avoidance, regional coordinators for task allocation, and a central optimizer for long-term scheduling. Results: higher throughput, graceful degradation on failures, easier incremental rollouts. The lesson: combine decentralized agility with centralized oversight where needed. So what's next? Expect more hybrid intelligence, emergent social behaviors and virtual assistants, improved MARL algorithms, standards for safe MAS deployment, and wider industrial adoption as tools mature. We might also see regulatory frameworks around multi-agent autonomy in safety-critical domains. If you're building for the long term, invest in observability, safety layers, and modular designs. To wrap up, multi-agent systems are a powerful paradigm for distributed intelligence. They unlock scale, resilience, and emergent solutions that single agents can't match. If you like this breakdown, hit like, subscribe, and comment with the mass use case you're most curious about. Want a follow-up deep dive or a coding walkthrough showing a simple moral example? Tell me in the comments and I'll make it. Thanks for watching. See you in the next video.